find the range. What the? Okay. The two times where you can't find you can't find the range is just when you have the x squared in there, and then when you're cutting off with the absolute value.
Exactly. So anytime you find yourself crossing off anything that's on the negative side, because that's not going to be relevant anymore, then that would be the case. But I mean, if it would be different though. So say instead, so say the original domain, Benji, had just been 0 to 6, right? And
Yeah, that
I
makes
had
sense.
said, oh, okay, x squared between 0 and 6. Am
Mhm.
I going to be cutting off anything negative?
No. So you just have
No.
to look at the negative when you're doing the problem, basically.
Yeah. So
Okay.
it will still be negative root 6 to root 6, but because I haven't lost any of that range, because I'm still going to be putting in values that will make the domain be 0 to 6, which incorporated all of my range, I can actually find the range. So I'm not like crossing off anything to the left of the y-axis.
Okay, that makes sense. And then just for the y absolute value, um,
Yes.
let's just say I had like -4 to 8. It would just go to 0 to 8, or how does
Yes.
that work? Okay,
Yes. The
just
absolute
clarify.
value in y, and this is another thing people miss. Think about it's best, I think, graphically. And if anyone's struggling with this, my recommendation is always just draw a little graph where the lowest is -4, the highest is 8. So if I'm thinking about making all y values positive, my new low is going to be down here at 0. But now my
Okay.
new high, in this case, it will still be 8 because -4 will go up to +4, which is still less than 8. But had it been -10, the new high would be 10.
Okay.
So the
I
mistake
got it.
people tend to make is they absolute value each extreme and tell me 4 to 8, which is not right.
Okay, so when you have the x, it's just getting mirrored, and when you have the y, it's just getting like pushed up, basically.
Positive values or zeros are staying the same and negative are becoming positive. Yeah.
All right, thank you.
And I should just tell you guys, I forgot until like 2 minutes in that I was supposed to record. So anyone who's watching because there a few people had a game and couldn't watch till later. So if you're tuning into this later, you missed like literally half a minute. So, but everyone else, I just wanted to let you know that I'm recording.
Wait,
All right,
real
what
quick.
else?
Wait,
Yeah,
can we go over S of X real quickly?
on the same page?
Yeah,
Yeah, of course.
thank
All
you.
right, let me just erase this. Okay. So again, the only thing impacting the domain is what's inside the F, right? So I'm going to put it between the extremes. And then the reason I feel like that's so important, I know you guys, a lot of you guys like to do things in your head, but this really gets you to try to figure out what the order of doing things is. So, what's the first transformation I would do in this case?
Get rid of the absolute value.
Yes, exactly. The only way I'm going to get at X is to first deal with the absolute value, which means this whole side goes away because I'm just taking to the left of the to the right of the Y axis and mirroring it. So right away, what do we know by the fact that I've just crossed that out? What can we say about the problem?
We're losing the range.
Yeah, I can't find it. Right. Can't find it because I don't have a graph in front of me. So I can't find the range. Okay, so then I say, all right, everything, the right stays exactly the same. So it still goes to 6, but I'm going to mirror whatever's there to the left of the y-axis. So -6 to 6. And then I will shift left 1, so subtracting 1 and from each side and then dividing by 2. So -7/2 to 5/2 would be your domain. And then the range you just can't find.
Okay, thank you.
Yeah. And feel free if you don't like have a, specific question on a problem. I'm happy also to make up something if you feel like, you know what, I'm a little bit rusty on blah, 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 blah. Just don't ask me, which last year people loved to ask me, hey, what's the hardest problem that might be on the test? Can you give us one just like that? No. Um, yeah, Ichu.
So on, I think it was on 1.14.
Yeah.
There was a problem that was we had like graphed three different inverse and its regular functions. And then like I think it was like number seven, where it was
Is this
like asking us,
the latest one I gave out? No.
yeah, I think so. Should be like a green packet, maybe.
Yeah, the 1.14, did you say?
Yeah, yeah, this
Okay.
one.
Oh, yeah, yeah.
I think it's number seven.
I don't think there is a number seven. Maybe you mean 1.13?
One second. Uh, pretty sure it was, yeah, it was the green packet. Oh no, 1.12. 1.13. Yeah, you're right. Yeah, you're right.
Oh, 1.13. Okay, let me just
Yeah,
quickly. That's because that's the one I remember where we were graphing inverses and things like that.
yeah.
Okay. 1.13. All right. Got it. Okay, number 7. Yes. The symmetry, right?
Yeah.
Yes. So if you had drawn all the graphs correctly, you should notice that all inverses should be symmetric across the line y equals x, which in
Yeah.
many ways makes sense because you're switch by the definition, inverses you switch x and y. So if you were to draw a line y equals x, visualize folding the graphs over that, and the graphs should line up.
So if you wanted to like describe the transformation, you would probably want to say like reflects over the line y equals x.
Yes, that's exactly what it is. It's just
Great.
how does a graph relate to its inverse? It's a direct reflection over the line y equals x.
All right, great, thanks.
Yeah, Sophie?
How do you know if an odd function is invertible or not? Or like
Yeah, great question. So it
why
depends.
odd
Like
function? Yeah.
not all odd functions, like some odd functions are, but some aren't. And so I'll kind of give you an example. Like, so what makes something an odd function if you look at the graph? Like, what should be the symmetry?
The origin symmetry.
Yeah. So I think of a simple graph that is both odd and is one-to-one, meaning passing that horizontal line test, is y equals x to the third. Like if I plug in negative x, that's equal to negative the function. So that's both odd and it would have an inverse. But there are other functions, like I could just simply, if you look at what packet, I think it was in 1.12. Like if you remember when I had you graph in part B, I said, if a function's odd, finish the graph. So you would have origin symmetry, right? I mean, this is going to be a very rough sketch of this, but so that would be completing the graph. But is that something that has an inverse?
No, because of the
Yeah,
horizontal.
yeah. So sometimes it could have an inverse, but an even function can never, ever have an inverse unless we put a restriction on it. Because by definition, if something has y-axis symmetry, it's going to fail that horizontal line test, right?
Yeah, thank you.
Yeah, so it even could, but I'm sorry, an odd could, but an even definitely a no. Yeah, Devin.
So when you have like 2 minus root 25 minus x squared, why is it that like I get if you have a square and a inverse, you'll need to have a domain restriction, But like, why is it? What's the reasoning behind that for why you need that?
Oh, okay. Because without a restriction, it wouldn't be invertible. So, for example, don't you agree that if I plug in -1 for x, that'll have the same y value if I plug in +1?
Yeah.
And so by definition, that fails being having an inverse, right? Because having an inverse means that every x value goes to a unique y value. So no other x value could go to that y value.
Oh, so it doesn't pass the horizontal
So
line
it
test.
would not, like, I wouldn't expect you to know how to graph something like this, but it's anytime you see an x squared, that means there are many, many numbers where both the positive and negative of that number would give the same y value. So without us restricting it, it wouldn't be invertible.
Okay, got it. Thank you.
Liam and then Benji.
So like on the quiz when we had to graph the like absolute value, why
Yeah.
would you like set an inequality with the domain?
Yes, you would say, how would you or do you?
Or like why would that or why would you set an inequality with the domain?
So I always set an inequality with the domain. Let me just make sure that are you asking like when we graphed, I think it was something
Yeah.
that, right? So so the only you don't have to, but personally I find the by setting that inequality up, that just makes me realize what the order is that I do things. Like a bunch of people I feel like I forget, I'm gonna mess. I say the domain was this. I kind of forget a little bit. But say it went from -5 to 3. I would set whatever's inside G equal to that. And the only reason I did that is to figure out what's the first transformation of the graph I do. So what's the first thing I have to do in order to get at X?
The -1,
Yeah,
right?
so the first thing was flip over Y-axis.
Okay. And
And
then
then,
the absolute value.
yeah, and then so that for me personally, I just find I'm less likely to make a mistake with the order of the transformations in the domain if I do that.
So just to like figure out what order you're doing
Yes,
everything.
that's the
Okay.
only reason. I mean, so it's not a have to, but it's helpful.
Okay, thank you.
Benji?
So for on 1.14,
Yeah,
6D, it's just the last problem.
yeah.
Um, I was just wondering, so I understand that it's neither, but I don't really get exactly why. And like I think it's the minus X, but I'm just wondering like if there wasn't the minus X part, would it not be neither?
So that depends. If it would so say it was so one thing when you put in I'm going to answer this a few ways. When you put in -x, right? You get the -3x changing sign, but not the -1, right? And then the denominator everything changes sign, right?
Yeah, that makes sense.
Yeah, so anytime you have so if it were even everything in the numerator and everything in the denominator would change sign, right? If I multiplied the top by -1 and the bottom by -1, I would get back to the original. But looking at this clearly does not, would you agree right away it's not even?
Yeah, I would because yeah, as you just explained, one's changing, but the other's
Yeah, I mean, you
not.
could even test it to see, okay, if I multiply the top and bottom by -1, that does bring me back to 3x, but now I got this +1, which is problematic, right? So it's definitely not back to the original. If it were to be, whatchamacallit, odd, that means that when I put in -x, it equals negative the function. And that means either it has to equal -3x plus 1 over 5x cubed minus x. In other words, distributing the negative to the numerator, or it would have had to equal keeping the numerator the same and distributing the negative to the denominator.
Okay, I get
And it's
that.
and it's not equal to either of those. So the main problem was the fact that the numerator really is a neither. You can't have, whenever you have an odd exponent and then a constant, that's a neither.
Odd exponent and a constant.
Like any
Okay.
function that has an odd exponent and a constant is a neither. the constant doesn't matter if it's an even function, if you have even exponents, because nothing changes. And so the constant doesn't change. But if it's going to be an odd function, everything has to change. And there's no way a constant changes because there's no x in it.
Okay, and if it was an odd exponent and a constant over an odd exponent and a constant, it still wouldn't work, right?
It still wouldn't work, right?
And just imagine it was 3x minus 1 over 5x to the third. It still doesn't work because of the numerator.
Yes, exactly.
Okay, thank you.
If it was 3x over 5x cubed minus x, then it would end up being even it because the whole numerator and the whole denominator would change, which means nothing changes.
Yeah, I get
So
that.
this would be even. Whereas, say I had something like this 3x squared, 5x cubed minus x. What would that be?
So the top's not changing, but the bottom is, so it's odd.
Yes, right.
Okay, thank you.
Yep.
All
But
right, perfect.
Miss Jensen, for b of x, it's odd, but the the denominator has a constant in it.
Yes, so a constant with an even exponent doesn't matter, right? Because that's not changing. It's the constant with the odd exponent. Because when I plug in negative x here, the top changes, but the bottom doesn't change, right? So constants are fine when I have an even exponent because it means nothing's changing. Constants are not fine when I have odd exponents because with odd exponents, we're looking for everything to change, but you can't change a constant.
Okay, thank you.
Yeah, so what I have, another way to think about it, on the top here, I have an odd. So think of minus over an even. So think of not changing or plus. And so a negative over a plus is still going to be a negative. So it's going to be an odd. All right, Ishu and then Nilesh. And then Jackson, I see you too. Yeah.
Could you possibly like create a problem that's similar to the one on the second quiz, number three, part C? It was the absolute value transformation.
3 part C. Yes, I actually brought my binder home so just I can remember. It was when I give you a domain and range. Right.
Uh, yeah, so you basically gave um like a graph of f of x.
Oh yeah. Oh,
Um,
this is transform a graph, you
yeah,
mean?
this is like the bat wings. It looks like the final graph, I think looks like.
Yeah, I can make
Yeah.
those. And while you guys try to work on it, or whoever wants to work on it, I can also answer if other people want to ask me something else too. But let me make something up off the top of my head here. So we'll see how this goes. Okay. Just kind of make a silly graph, but all right, I may even make it a little bit more challenging than that one. I feel like you guys can handle it. Let's Okay, so this is just everything's just going up by 1 unit, just so you know. Okay, so let's see. What if I said, let's do equals absolute value 2. All right, this is looking a little gnarly, but I feel like you guys can do it. Um, Okay. So try that. I'm going to give you a little time for those who want to try it. I'll just leave it up here. And I'm also happy to answer other questions too. In the meantime, Nilesh, did you have a question for me?
Yeah. Could you go over 4D on the second review packet and like specifically like talking about when like when you can find the range versus when you can't find the range?
Yeah, let me get to 4D. Oh yeah, so I don't want to open it up because I want to keep this up, but I can write the problem down. So that was this one, right? Y equals 2f of x squared minus 1 plus
Yeah.
7. Yeah.
Yes.
Okay. So always start by putting inside the function between the extremes of our domain, which is -2 to 5. All right, Nilesh, tell me what you would do first.
Yeah, first probably like shift one. So like put move one on both sides. So like it'll be -1
Mm-hmm.
and then 4.
Add 1.
Oh, sorry, 6. And
Yep.
then but like because this is like a squared graph, it can only go up, it can only be like 0 and positive, right? So doesn't that -1 become 0?
So that -1 just gets X'd out first because there's no way when that an input is ever, when I put it into the function and square it, there's no way that input is ever going to end up being a negative.
Right.
So I'm going to go like that. You're right. Your instinct is right there that -1 becomes irrelevant. But right when that happens, I say to myself, can't find the range because I just lost part of the graph.
Oh, okay.
So it's they actively realizing there was stuff to the left of the y-axis that now is not going to be relevant. And I don't have a graph in front of me, so I can't find it. But
Okay.
then I think about if x squared has to be less than or equal to 6, then that means x has to be less than or equal to √6.
Right. Which
But
means
how far negative can I go if I'm going to?
negative √6, right?
Right. Yep, exactly.
So, okay.
And that's it. But
So
it's the fact that I had to cancel out that left side that means I can't find the range.
so that also happens with absolute value, right? For like A, you can
Yes.
find the range either.
Yes, exactly. Because I crossed out that -4. Right.
Right. Okay.
Yes.
Got it. All right. Thank you.
Yep. Jackson, do you want to ask something while people are working on this graph?
Oh yeah, so for 1.12 review,
Yeah.
I was kind of confused about how to go about thinking about question number 18.
All right. I'm going to look, see what this is. The 112. 18. Actually, maybe I'll pull it up here. Give me 1 second to pull it up. 112. You said 18?
Yes.
All right, give me a second. I think that's the one printout I don't have with me, but I'm just going to look on my computer. 112. Oh yeah, this is one. Oh yeah, this is one that I talked a little bit about earlier about can an even function have an inverse? Can an odd? That problem?
Yes.
Yes. So even function, talk to me about the symmetry of an even function.
So you have to have symmetry over the y-axis.
Yes. So anything that you can flip and line up over the y-axis, could that possibly have an inverse?
Well, I said yes because you could put a domain restriction on it, but it said no.
Okay, but if you put a domain restriction, it's no longer even.
I see. Okay.
Yeah, so you're not wrong, but then it's no longer even. You just made it not even anymore.
I see.
So yeah, you're right. So you could even functions to start would need a restriction to have an inverse. So even functions, if we leave them even, can't have an inverse.
Okay.
And odd functions, it depends. They certainly could. Like y equals x cubed definitely is invertible. However, like one we did earlier in that packet where I had part of the graph and I said, okay, make it an odd function. It looks like this. That definitely has origin symmetry, so it's odd, but it's not invertible.
Okay.
All right, I'm going to get to other people's questions, but how about, are we ready to look at this graph here? Okay, so talk to me about the first thing we do. What would you all do first?
Do you shift it over first?
Yeah, talk to me how I would shift it over.
So you'd shift all the points right one.
Yeah, and if people were struggling with that, you could always start by saying, okay, this went from -3. I guess it did go from -3 to 3. So you'd shift it over 1. So it's going to go, when I do that, it should go from -2 to 4, right? I'm actually going to do the first two steps in one step, just so my graph doesn't look crazy here. Just so I don't have too many graphs in one. Because what would be the second step after I shift everything over 1?
Multiply by 2.
Multiply it by 2, exactly. So I'm going to horizontally stretch it. So it should be 8, -4. So let's do that. If I'm gonna stretch it out here. So this point, if it started out going to 4, so now when I multiply it by 2, it's gonna go to 8. Okay, so then how about 2? That will go 3 and then to what? 6? Yell at me if I'm making a mistake, anyone. So 1, if I'm doing this, goes to 2. Am I good so far here? Um, and
Yeah.
then -1. Oh, how about -1 when it goes to 0? Then what happens?
Stays at 0.
Yeah, 2 times 0 is 0. And I'm going to make this is the curvy part. So I'm going to do my best to make this extended curve. -1, this one would go to this point here would go to, actually, no, let's do, yeah, no, we'll do the -1. -2 goes to -1, but then multiplying by 2, it goes back to -2. So that point's actually staying nicely there. And then -3 goes to -2, but then multiplying by 2 goes to -4. All right, are you guys with me on that? Okay, great. Now we've done that. What's the next step here? And then I'll deal with the range. What's the next step?
Don't you just mirror?
Value.
Yes. So this positive, and honestly, if you're doing a graph, when you get to the mirroring phase, do yourself a favor, because this will avoid kind of making some obvious mess ups. Just mark the positive, because that's not changing. So anything to the right of the y-axis or on the y-axis is staying the same. And then you're just mirroring it to the other side. So this actually, because it was symmetric already, will stay. And then this was at 4, 5, 6, 7, 8. This was at, I think this was at, yeah, that was at 6. So we're going to be at -6 for this top point, -6, 2. Sorry, this is a little messy. And then the last one will be at 8.
Miss Jensen,
Yeah.
just a heads up that the meeting's gonna end in like 4 minutes for like
Oh,
it says on the Zoom thing.
all right. Let me see. I may have to. That's weird. Maybe I didn't log into, but I did log into my memo.
You can
Um,
probably just restart it or something. I don't
Yeah,
know.
if I log out, I will just I'll just pop right back in. Okay, I'll just restart it. That's weird. That's never happened before. So in a few minutes, I'll have time to finish this graph. So if I pop out, guys, I'll just pop right back in so you guys can do the same because it probably will end the meeting for everybody. So just come right back in. Um, okay, so next step. What do we do with the y values?
Multiply by 12.
Multiply. Oh, sorry, that's
Oh,
an absolute
2.
value. Multiply by 2,
Oh,
right?
yikes.
So that would be yeah, that would be quite big. So I'm just gonna multiply by 2. So it's just stretching it. Again, my apologies. Now I'm trying to go quick to and then this would be down here. That would stay at 0. This would come up at 4, and that would go down at -2. So I'm stretching it. Oh, and finally, what's the last thing I do?
Absolute value.
Yes, absolute value and y. And another huge piece of advice is mark everything that's positive first so you don't accidentally misconnect things. And then the negative comes up as positive because that's what absolute value and y does. So this will come up as +2. And same with this one. And there's your beautiful graph there. So notice, another thing to notice, what was the last transformation I did in the domain?
The
What-
absolute value.
yeah, absolute value, which notice because of that, because that was the last thing I did, this graph is an even function. It's symmetric across the y-axis. So that's kind of an important thing to make note of is
Do you always do absolute value last whenever you're in domain?
no, it all depends on how it's positioned. Like, so say the inside had been like x plus 2, you would do the absolute value first and then shift left 2.
Okay. And then my other question is on the test, it'll be like okay when we're like have like a million graphs on it and stuff, right? As long as we make our final graph clear.
Yeah, I mean, I'm not going to have something. I mean, this was this was a lot going on in one graph, but yes, that's fine. Just somehow like indicate which one is your final graph. Marone. Oh, Parker, I
I
missed
just
you.
had a really quick question.
Yeah.
What do you think is like the most common mistake that like you've seen people make on the recent quizzes?
Messing up with the absolute value.
Okay.
In a big way. That would be the most common, or messing up with the range of problems that have a variable in the denominator.
Like K problems.
Not K, actually, people way improved with those. It's when there's this, like when we did problems like this is not going to be the problem, but something like this. Say it was finding the range of 1 minus,
Oh,
it was like something like x, gosh, I can't remember. X like